Okay, what we have here is we have a toilet tank and we have a reservoir in the bottom because when we flush, the water is going to go into the reservoir here just like it would go into a normal toilet. And here we have the toilet tank lid, and here we have a gasket between the toilet tank and the toilet tank lid. And the purpose of the gasket is to give us an opening on the side right here because we want to get some tubing from outside the tank into the tank. This tubing basically just goes down into the tank, and it's actually connected to a larger hose to give a little greater volume, but it just comes down here and it comes to an end. The opening just lays down here on the end. And then of course the tube goes on up and it goes in here into this reservoir, which at the present time is a little smaller than a shoebox. The typical reservoir might be a little bit larger. And this piece of tape right here covers over two small holes in the top of the tube. Now the reason that we want two holes in the top of the tube is because the water level in the reservoir here and the water level in the tank, which is approximately here, between the two of them, they want to seek out the same level in this tube, and if we had air trapped in the top of this tube, that might not occur. We would like that water level to be exactly equal to the level of the water in this reservoir and this reservoir to minimize the air pocket that's in the top of this tube. Now normally the device is going to have a small air vent that will simply burp the air, and when a vacuum occurs it will pull the air vent closed. But in this relatively crude prototype, I'm just using a piece of electrical tape, and now that I've allowed the air out, I'm going to secure the tape back over the small openings to make sure that it stays closed. So now what's going to happen when I flush the tank, all the water in the tank is going to come down here into this pan, and in doing so the water level in the tubes that are inside the tank is going to drop, creating a vacuum that will then start the siphon, and the water in this reservoir will enter this tank quite promptly. Again, this is a 3/8 OD copper tube. It's a relatively crude prototype, and I've put two of them side by side. The actual product, we will probably do a little experimenting. It'll be a much larger tube so that everything happens a little more quickly. But even with these two small tubes, we can demonstrate the principle of this device, and we will also see that the water does empty relatively quickly anyway. I expect it to take approximately 25 seconds. So now we're going to flush. We're going to see all this happen. There's all the water coming out of the toilet tank. There it's empty. Now the flapper is closed, and we see that the siphon was initiated, and it is now in progress, and it is emptying the water in the reservoir into the toilet tank. In a normal application, we would also be making up water through the normal source, which usually takes sometimes up to a couple of minutes, but as you can see, this whole reservoir is now draining in a matter of approximately 20 seconds. Now this is just a demonstration to show the operating principle of the siphon water saver. Thank you for your attention.